All right, now that we've already introduced ourselves, the whole point of today's talk that we want to do is to give you a very high level overview of what Azure provides in the AI ecosystem. So, we want to tell you guys about everything that is out there so that in case you want to apply something to your applications, you know what to choose. Like when you know everything that's out there, you know what to apply when. So the use cases and how you can go about applying them, that is something that we want to cover today. So there's four parts to this. So there's the Azure machine learning, the Azure AI infrastructure, the applied AI, and the Azure cognitive services that we'll be covering today. So Rida will start off with the Azure machine learning without further ado.
Okay. So starting off with Azure machine learning, the first question that I want to tackle is what exactly is machine learning? Um, I I hope that all of you are a little aware of what we do when we're working with machine learning and what is being created when we're coding or when we say that we have built a machine learning model. But if I were to explain to you what we do in a traditional method of creating a machine learning model, so we have different techniques that we apply to different domains, right? So we've got classification, we've got prediction, where we forecast, and we use it in a lot of different domains, almost in our daily lives that we might not be aware of, but it's being used in a lot of places. So starting off, the first thing that we have is the data. So we have some data that we need, that we require. It could be customer data, it could be some sort of patient data, but all of this data is required for the model that we need to build. And it has different features that we need that will affect the prediction or the classification or whatever task that we have, right? So when we eventually read the data, we go ahead to process it. So when we talk about processing the data, we perform different operations on it, where we are transforming the data, we're cleaning the data, and what we're doing is basically fine tuning it, because the data could possibly be raw, right? It could be of different types, or it wouldn't fit the conventional models also. So we need to transform it in the sense that it would be good for computation firstly, and secondly we need to fine tune it so that it fits our desired task. So the task that we have, or we want to build a specific model, it can have certain specifications, it can have certain requirements from the data itself. So we need to keep in mind, right from the type of data that we deal with will affect directly the performance. So the performance of your model, the quality of your model, depends directly on the quality of the data that you have. So because of this, we are performing various pre-processing techniques like cleaning the data. We drop out a few features. When I say drop out, I mean that there could be some features in the data that do not affect my task. I have a prediction task, but someone's address that is there in the data doesn't really affect the prediction of if the person will possibly shop in the same, in the place again or not. So if I want to do that sort of prediction, the address of that person, or let's say perhaps the phone number of that person, doesn't affect the data directly, doesn't affect the model directly. So I don't need it. It doesn't affect it in the sense that it's increasing the performance, or its absence doesn't really affect it negatively. So what we can do is that we can remove this, because we don't need it, and that's called cleaning it by dropout. And sometimes there are a few values that are missing. Certain data rows might not have a specific value, so that again can cause issues in the performance of the model. So that can either be again removed, or you can fill it in by using the other values that you have. Then you can move on to normalization. You have standardization. You want your values to be in a specific range that again allows the model to perform better. And perhaps you want your values to be binary, 0 or 1. That's it. You don't want your values to be of any other value. That is really because it is noticed that computers perform a little better with binary values. So you could change it in terms of features where you have, like, for example, true or false. So rather than writing true and false and taking that string as the main thing for computation, you could change it to a binary value, 0 and 1, and then you can use it for the computation process, and that is much faster, which again improves the overall performance of the model. And once you do this, you now have processed your data, you have prepared your data, right? So then you can take it on to the next level, which is the splitting of the data. So the data is split into two parts. You've got your training data and you've got your testing data. And this split is done either conventionally, which is, generally we tend to follow a 70-30 ratio. So people tend to, follow the same as well. You go for 70% of the whole data is your training data, and 30% is your testing data. You could, tweak it a little. You could go to an 80-20 or 60-40, depending on how it affects your performance of, the model's performance, because you can change it according to your requirements, and you can change it and see how it affects your model. If it's good enough, then yes. But then again, you have to keep in mind overfitting, and you have to see if the model tends to remain generalized model, or if it is performing really well only on the training data, which again is not good for us. So keeping this in mind, you've got your data that is split into training data and testing data, and then you move on to the algorithm that you've selected, right? You have a specific algorithm that you want to work with. Depending on what task you have to choose the algorithm that you want, and then you've got your data, you've got your algorithm. Then you move on to training the model that you've built. So once you've trained it, the next step is to evaluate it, because you need to see how well the model is performing as well. So there are a lot of evaluation metrics that you can use. We normally use accuracy and perhaps even confusion metrics as the most common way of determining how well it is performing, right? Even ROC curve. So what we do is that we map points to see how the model is varying across different parameters, different features, and how it performs the task that we have. So this is what we have when we're talking about building a model traditionally using machine learning. And when I explain all of this to you, it's we're all aware of it. This is what we're working with when we're working with ML models. It's quite normal for us, and we know the entire procedure. This is what we follow. This is the roadmap that we have. But it has a large amount of code to it as well. If we sit back and realize, the more complex the models get, the more number of lines that we have to keep writing in order to make even a small change to the model regarding the data, or even any type of visualization that we have. So that can get quite time consuming, or perhaps even a little tiring for us, right? What if I told you that all of this can be automated? Like the whole thing that I just explained to you, the hours and hours of coding that you would have to do, the hours that you would have to wait for training, because trust me, training takes a lot of time. And then eventually when you reach a score that's not good enough, you have to keep iterating it, right? It's a process that you keep doing again and again to reach a satisfied position. So what if I told you you don't have to do that again and again, and it's so much of your effort and time? You don't have to do that, because all of that can be easily automated with what is provided by Azure Machine Learning. Azure Machine Learning essentially provides us with automated end-to-end machine learning lifecycle. So when I say automated end-to-end machine learning lifecycle, I mean that it firstly automated as in we don't have to write a lot of code. Most of the work is already done, or it is done automated by us having to perform specific tasks but not essentially writing code. And end-to-end lifecycle means that right from the start, from the input of the data that I'm giving to the model, and to the output, to the deployment even perhaps, is all encompassed and completed within this one interface itself. So you don't have to worry about 10 different things and how you are going to get into getting an API, getting the data, training the data, getting a different GPU for this, so much of computation, so much of workload. You don't have to worry about that. All of that is very well handled by this one interface alone, that we call Azure Machine Learning Studio. So this studio provides you with a work space where you perform the tasks that you have. So let me give you an example so that you understand with what exactly we're working with here. So let me say I want to perform a logistic regression task, right? So when I'm working with the Azure Machine Learning Studio, all I need are task blocks and arrows that provide a lifeline. These are the only two things that you need to work with and you need to focus on for building your entire model from the start till the end, trust me. So when I talk about this specific example, I need my data first. So I take the data block that is present. There is a side panel. Okay, so I have my workspace, and to the side of my workspace, there is a specific panel where all the blocks are present. Now these blocks are, data blocks. They are algorithm blocks. They are action blocks. And depending on what the specific task is, I will keep using that block. So I'm going to start with the data block. So I select a specific data set that is provided, and I take that and I put it and I just drop it onto my workspace. Right. So then that means that the studio workspace has read my data. It has read the data set, and now it has the data set as the generally how we read it as perhaps dt or df, or however we did it. It has it stored that it will deal with. And then we move on to the processing part. Like I explained to you in the traditional method, there's so much to do. Right, in here you just have to take that specific block. So if I have a block that says drop out, I just have to select it and I have to drop it here, and I have to just specify what are we dropping out. If I have a standardization process of operation to compute, I just have to pick up this standardization block and I just have to put it here. The only thing that I'm doing is selecting what needs to be done. If you are aware as a professional of what needs to be done in the model or how the model needs to be, you just need to know what steps are to be performed. So you just pick up that step and you put it in the workspace, and then you connect them via arrows, right? And these arrows, from one task to the other task, each block forms a pipeline, and this entire pipeline follows a specific path, and eventually it makes up your entire model. So then you've got your data, you've processed it, now you need to split the data, right? So there's a specific block for this as well. You have the action block which says split the data. So you take that block and then you drop it. You drop it, and then your data is automatically split. You just have to specify what ratio you want for the split, and now your data will be split into testing and training data depending on that ratio. And similarly, you just keep on continuing with each pipeline. You continue with the evaluation metrics, you go with the deployment part, you go with the training, you go everything. You just need to pick a block and then you need to drop it in the workspace, and that's it. That's how it works. It's a drag and drop policy that the machine learning studio follows, where you don't have to write the code for it. You just need to know that what exactly should be done in that specific time. If you are clearly, if you've understood the entire concept of what the model requires from you, all you have to do is that take that specific task, that block that exists in the panel, and drag it and drop it to the workspace. So doing that, right from reading the data to the deployment block, you have your entire model built entirely from blocks and from your arrows, which are the pipelines. So in this manner, you aren't writing any code, but you already have a model ready in a matter of minutes. You don't have to do a lot of work. It's quite simple. It takes a little time for training the data because the computation that's required in the backend. So that happens on its own, and it takes a little bit of time, and a little more time on the deployment part as well. But then again, all of that is automated, and you don't have to worry about it. So that is what the machine learning studio was, and I try to explain it to you as clearly as possible, and I hope that you guys can go and check it out how it works. It's quite simple, doesn't really require a lot of effort from your side, so don't worry as to it's going to be very complicated. It is much easier and simpler than the traditional machine learning techniques and the process, but it only requires some sort of understanding from your side as to what is to be done when you're building the model. So moving on to the capabilities that are provided by the machine learning studio that is provided by Azure, is the first one is the collaborative notebooks. So when we're talking about collaborative notebooks, it basically means that if you have any specific notebook that you worked with, that you have your code on, and you want to integrate that code, it is quite simple. You can just integrate that with the Visual Studio Code, open it over there, and directly you can open it here, and it is simple to merge the code along with the blocks that you've been working on. So your model and that code can be merged, and you'll have the combined product in the end. So you can work that way. And in fact, if you want your choice of deployment, it is quite easy, because if you want to tweak the deployment a little bit, if you want a separate website for the deployment, You can easily write your own code in a notebook and then integrate that with your model, and that's done. As easy as that. And then you've got your drag and drop machine learning. So when I was explaining blocks, right, so you drag or drop from the panel of all the blocks that are present, and then you put it and you drop it on your workspace. So that is what Azure Machine Learning Studio deals with. The entire mechanism is simply drag and drop. Then you've got your ML ops. So the machine learning operations that come into play when you're working with the team, when you're collaborating with the team, the management that you have, the operation that you have to perform. The team isn't situated in one place, and they all need access. All of that is quite simply made easier by using the services that Azure provides. So you don't have to worry about that aspect separately. Then you've got integration with other Azure services. So this means that if I want to, if okay, suppose I have another Azure service and I have my machine learning model, right? If I want to integrate these two, I can do that. It is possible. For example, Azure provides hosting services, right? So let's say I've created a machine learning model and I have deployed it on a website, and then I can host this website. So basically, Azure allows us to integrate this with the other services that it provides, and that way we have a project that has multiple services that Azure provides us with. The other capabilities are reinforcement learning. We also have enterprise grade security, and a few more are automated machine learning. So we've gone quite into depth explaining how this is automated and how it's different from traditional machine learning processes. Then we've got data labeling. It's quite easy because we are easily able to monitor the labeled data. We're dealing with data that is labeled and cleaned and processed, so we don't have to worry about that. Then we've got auto scaling compute. So it's quite easy for okay, so when you're working with a project or a team, or if you're creating a project, there are times when you'll have to scale your project depending on the response that you have, right? So it is quite easy for you to scale up your machine learning model using Azure, depending on whatever requirements it has. Then we have hybrid and multi-cloud support. You can easily put it up on your Kubernetes containers if you require it, and it has multi-cloud support as well. And lastly, we've got responsible machine learning and cost management. So responsible machine learning basically means that how we are able to assess the model fairly. So when we are evaluating the model, it is fair. We're doing it quite fairly. And the entire process of training and building the model is completely transparent. So we know what is happening. We understand what is happening first and foremost. Other than just knowing, we also understand what's happening. So that is quite a big advantage that we have, where the entire process of machine learning is responsible as well. Okay, so I hope that you got a little idea of what I was trying to convey with what Machine Learning Studio is. Over to you now, Annanya. You can continue with the Azure Cognitive Services.
Yeah, thank you. So yeah, that was a great overview of what machine learning, what Azure machine learning provides to us. Looking at the time constraint, I'll just quickly go over whatever it is that the Azure Cognitive Services also provide. So the Azure Cognitive Services basically has to do with human cognition. So anything that humans can do is something that we expect from these Azure Cognitive Services. That those are the kind of functionalities that Azure Cognitive Services provides to us. So let's take them one by one. Coming to the decision Azure decision cognitive service. Rida, next slide. Rida, the next slide. Yeah. So the previous one. Yeah. So there's three types of decision. There's three parts to the decision cognitive service. First one is the anomaly detector. So essentially, what the anomaly detector does is that it tries to pick out that one outlier or something that's out of ordinary, and try and kind of highlights that and brings attention to that specific outlier. So in cases of like credit card fraud detection or some sort of a consumer requirement change, that's when anomaly detection comes into picture. So what the Azure Anomaly Detection Service does is that it basically chooses from all of the required anomaly, like all of the present anomaly detection algorithms, and picks out the best one, and it kind of helps to provide very high accuracy. That when you can directly embed it into your applications without any sort of pre-processing or any sort of extra manual work that you have to do. Just like how Rida spoke about machine learning, that's how you can basically in a very automated fashion, you can provide anomaly detection to your applications. The next one is content moderator. So there's different types of content moderators. There's image content moderator. So that's basically when there's potentially any sort of offensive images that you want to filter out using machine learning based classifiers. That is also something that you can do without really knowing machine learning, right? You can just directly apply the machine learning the image moderation service, and you'll get your result. There's also the same thing for text moderation, and in fact, Azure AI provides the Azure Cognitive Services. It provides you with a content moderation of around 100 languages, which is not generally seen in most cloud services. And then there's video moderation. So it's pretty much the same thing, but in terms of videos. So it kind of filters unwanted videos. And then there's human review tool. So in case of human review tool, any mistakes that you can do possibly, say okay. So say you're trying to provide some sort of a machine learning solution to a problem, and you have an accuracy that's not optimum, that actually could be improved. So that is something that your like that can be like the human review tool can actually help you with. So the next cognitive services provided is a language, as you can see on the screen. So there's 4 types to this. The first one is Lewis. So Lewis language understanding is basically the Lewis service. You can add conversational AI to your apps. So when I say conversational AI, I don't mean just not just your basic rule-based chatbots, but uh, when when I say conversational AI, whatever you tell the chatbot is not just a chatbot, but whatever you tell your model for that matter, it can comprehend it. So I'll tell this to you with the help of an example. So say if you want to book a flight from one place to another place at so and so time, that specific phrase can be like rephrased in like 100 different ways. No two humans say the same thing. Say like give a command in the same way, right? So that can be so that sort of understanding is something that Lewis provides. And in case of Lewis, what it does is that it can pick out specific entities from your utterance. So when I say utterance is the sentence that you say, the command that you give to your model. So out of from that specific sentence, it can pick out the important information and use it to do the next task. So text analytics also does that. That's a part of what text analytics does. It can also remove like important information from your utterance and use it to do specific tasks. On the other hand, this Q&A maker. So Q&A maker uses like a knowledge base. So you can give it a set of questions and answers, and give it and feed it into your application or feed it into your chatbot, and anytime that specific question comes, you'll get that specific answer. So that's the difference between Q&A maker and language understanding. One is rule based, and the other one is you just have to keep training it with like hundreds of different kinds of utterances, and you'll get your required task done. And translator, as the name suggests, it translates from one language to another as and when you give it information. Also, I'll go to chatbots at a later point. Coming to speech, so there's speech to text and text to speech. They're just APIs. You can just create the APIs and add them directly to your applications. You can deploy them very seamlessly. Speaker recognition, the service helps you to differentiate between two different speakers just by listening to their audios. And this is done very accurately as well. And then speech translation, as in language, in the case of language, the translation was done by like through text, and over here the translation is done when like through speech, basically of the speech. Yeah. Next slide. Yeah. Now the last cognitive service is vision. Face. It's nothing but face detection, face recognition, and all of that. And then computer vision, any computer vision applications, there's object detection, object recognition, all of that comes under computer vision services. And in terms of custom vision, it's basically applying a use case to your computer vision. So when you want to make specific, when you want to have like very specific use cases, or like when you want to solve specific problems with the help of computer vision, that's when you use you can give those scenarios, those custom scenarios, and get your solutions out of it. So yeah, that is an overview of what Azure Cognitive Services provide as a whole. Over to you, Rida.
Okay, so talking a little about AI infrastructure, there are three main topics that we need to focus on when we are, taking into consideration the infrastructure of AI. The first one we have is the product, the second one is models, and the third one is the platform. So the product, essentially, when we're talking about the product, it means how we are going to infuse AI into the product. So let's say we are working on creating a product, on building a product. So we need to see on how we can get to put some sort of AI in there, how we can improve it by using AI there. So that is usually done by a lot of companies by using pre-trained models. So what they do is that they already have models that they've worked on, that they've created, and they simply just take it and they tweak it a little for their specific task, and then they use it again. Moving on to models, we have two types of models. The first one is the fine-tuned model, and the second one is a pre-trained model. So when we talk about fine-tuned models, like I just said, it means that we already have certain pre-trained models and we're just fine-tuning them. We're just tweaking them a little bit to use them across the entire company. We don't have to limit it on what use we have for the pre-trained model. We can have any sort of domain and we can apply that pre-trained model there without actually having to work from scratch. So this allows us not only to save time but also have a much better model. The second one, like I said, is the pre-trained model. The pre-trained model, we're working with this essentially because it is a little, it's understood that models, large natural language models, perform much better compared to models that are a little smaller sized. So it's much better if we have something that we are already working on. We already have something to begin with, not something that we're starting right from the ground. So we don't have to start from scratch. We already have something in our hands and we're just we're building up from it. And the last one we have is the platform, sorry. So the platform is how we're working on it, right? So we already have our models, but we also need, like, in the company we've got scientists, we've got data scientists, we've got data engineers who are working with creating models. And what they do is they need to work on techniques as well. They need to work on state of the art techniques, on how they're going to optimize it. They need a service, they also need a computer. So it's quite complex when we are actually talking about the system software essentially. And the last one is the large scale infrastructure. So basically, when we are working with models that are of large magnitude or have so much computation, right, they need a large scale infrastructure. You need a lot of GPU, CPU, a lot of computing power. And that has a lot of components. The first one is you need a cluster of GPUs, and one such example is the NVIDIA. And the next one, you need a link connecting the different GPUs, and you need a network with different nodes, and they also provide a sort of connection for your GPUs. So that is a very broad description of the AI infrastructure that we are cutting a little because of the time constraint. And moving on to the last topic, Annanya.
Yeah, so this is the final part of what we had to convey today. So Azure Applied AI Services are essentially, they're meant to accelerate the development of scenario-specific AI solutions. As Azure Applied AI Services are built on top of already existing AI models that are at the core of Azure AI products and services. So when I say this, I mean like they're built on they're built on speech, they're built on all of the all of the cognitive services that are already present. So over here, there's like 5 examples that we have here. The first one is the Azure Bot Service, which is actually built on Azure Cognitive, on language, basically on LUIS. You can integrate LUIS, Q&A Maker, and all of that directly into your bots. You can use the Microsoft Bot framework to do that, and also the Azure Bot Service, as we just mentioned. Then the Azure Form Recognizer, it basically helps you to pick out important information from documents. So this could be like bills, there could be transactions, there could be any important documents, and you just have to remove like pick out important details, and all of these details are directly populated onto a database. So that is what the Form Recognizer does. The Azure Metrics Advisor uses it uses the anomaly detector, and it helps you to pick out things that are not required, or any sort of like unwanted data. It helps to classify that. Azure Video Analyzer basically helps you to caption videos. So this uses computer vision as well. So these applied services are built on already existing cognitive services to make things for businesses, or any sort of users easier, instead of using them from scratch and actually building them. So yeah, I think that is what we have to say about Azure. That's what I have to say about Azure Applied AI Services in a brief. So yeah, with that, we've come to the end of our session.